Hello students, let us discuss quantum numbers. After the discussion about the orbitals, let us find out what is these quantum numbers. For this, we need to explain the following terms. First of all, just recall the word what is an orbital. An orbital may be defined as a region around the nucleus where the probability of finding of electron is maximum. So, orbital is different from orbit as we have discussed in the previous video. Orbitals are of following type, that is S, P, D and F. The structure of S is spherical, P is dumbbell, D is double dumbbell. As we have discussed in the previous video, S orbital because it have only one orientation, because it is non-directional. So whenever we are making an orbital diagram, we'll make a single box for the case of S orbit. Because P orbit have three orientation, that is, if the dumbbell is on x-axis, that is Px. If the dumbbell is on the y-axis, then it is Py. If the dumbbell is on the z-axis, then it is Pz. So because of this three orientation, we make three boxes for the case of orbital diagram for the P orbital. Here three boxes represent, one for Px, other one is Py and the third one is Pz. So whenever we are making a orbital diagram for the P orbital, we'll make three boxes. D orbital, as D orbital of double dumbbell shape, as we have discussed in the previous video, it is of 5 types because of 5 orientation, that is dxy, dyz, dzx, dx square y square and dz square. Because of this 5 orientation, we have to make 5 boxes. You can see there is 5 boxes, and here the first one represent xy, dxy, yz, dzx, dx square y square and dz square. So like this we will making 5 boxes for the case of D orbital. Next, in the case of F orbital, but the structure is not there for us to discuss. So we'll directly make, there are 7 orientation in the case of F orbital. Therefore, we'll make 7 boxes. 1, 2, 3, 4, 5, 6, 7. So total 7 boxes are made in the orbital diagram for F orbital. So to describe each orbital in an atom, in different orbitals, we need a set of numbers which is called as quantum numbers. Let us discuss what are the type of quantum numbers are there. First one is principal quantum number, second one azimuthal quantum number, third one magnetic quantum number and the fourth one spin quantum number. Let us discuss these in detail. First one is the principal quantum number. What is this principal quantum number? As it is described in the case of Bohr model, it determines the main energy level, or we can call it as orbit, in which the electron is present. So, as the orbits are represented by letter K, L, M, N, the quantum numbers, that is the principal quantum numbers, are represented by small n, which is equal to 1 for the case of K, 2 for the case of L, 3 for the case of M and 4 is in the case of N orbital. So, the principal quantum numbers is nothing but the numbers specifying the orbits, or we can say shells or energy levels. So, thus the principal quantum number determines the main energy level or orbit in which the electron is present. Next is azimuthal quantum number. It determines the angular momentum of the electron. It is represented by small l. The value of L gives subshell in a given energy level. The subshells are, that is, S, P, D, F. So, if the subshell is S, then the azimuthal quantum number, that is L, is equal to 0. For the case of P, it is equal to 1. For the case of D, it is equal to 2. And for the case of F, it is equal to 3. So whenever a azimuthal quantum number for an electron is equal to 0, it represents that electron is present in S subshell. If whenever an electron is represented by azimuthal quantum number 2, it shows that the electron is in d orbital. So that is all about azimuthal quantum number. So azimuthal quantum number gives the value for subshell. For S, it is equal to P. For S, it is equal to 0. For P, it is equal to 1. For D is equal to 2. And for the F, it is equal to 3. Next is magnetic quantum number. It is a quantum number which describes the behavior of electron in a magnetic field. It represented by ml. As the electron shows behavior in the magnetic field, it is represented by ml. For in the case of s orbital, because there is only one orientation, so I told you we will be making a single box for it. So in the case of s orbital, as L is equal to 0, that in the case of azimuthal quantum number is equal to 0, and therefore its magnetic quantum number is also equal to 0. So the ml value for s orbit is equal to always 0. But in the case of p orbit, where the value of L is the azimuthal quantum number, the value of ml is -1, 0, +1. That means here three possibilities are there. If the electron is in this orbit, then it is represented by value ml is equal to -1. If the electron is in this orbital, we can say that the ml value is equal to 0, and if it is in this, we can say that ml value is equal to +1. So there are three possibilities in the case of p orbital. Therefore, there are three ml values, that is -1, 0, +1. So when L is equal to 1 and the time, the possible ml values are -1, 0, +1. You can check the value. It is 1 and ml is also starting with 1, but -1 and ends with a +1. So it is easy to identify ml when the L is given, because when L is 1, so ml will start with 1 only but negative value and ends with a positive value of that. So if L is equal to 1, ml is -1. It starts with -1 till +1. So there are three values of ml, possible ml values for p orbital. In the case of d orbitals, as there are 5 orientation, therefore we have made 5 boxes here. So in the case of azimuthal quantum number, that is L value is equal to 2 here. So the ml value will start with -2, -1, 0, +1, +1, +2. As I told you, L is equal to 2. You have to start the ml value with 2 but the negative value and end with the positive value of that is +2. So when you find if the electron is in this orbital, so we can say that its ml value is -2. If it is in this, -1. If it is in this, 0. If it is in this, +1. And if it is in this, +2. That means the electrons are present in a particular energy level in a particular orbital. So depending upon the position of electron, we can say that the electron can be in any of these orbital. For the f orbital, because there are 7 orientation, therefore 7 boxes are made. As the azimuthal quantum number, that is L, is equal to 3 for f orbital, therefore the possible value of ML are -3, -2, -1, 0, +1, +2 and +3. Since I told you whenever L is equal to 3, ML value will start with 3, but the negative value and ends with the positive value of that. That means it starts with -3 and with +3. So if the electron is in this, we can say that its ML value is -3. If electron is here, we can say its minus value, its ML value is -2 and so on. So depending upon the position of electron in a particular orbital, we can give its ML value. So from this we have concluded that S, P, D, F orbitals are there. So which is called as subshell, where L, that is a azimuthal quantum number, for S is equal to 0, for P it is equal to 1, for D it is equal to 2 and for F it is equal to 3. ML value can be determined with the value of L. If L is equal to 0, ML is also 0. If L is 1, then ML is -1, 0, +1. If L is 2, then ML is -2, -1, 0, +1, +2. And if L is equal to 3, then ML is equal to -3, -2, -1, 0, +1, +2 and +3. So these are the quantum numbers which we have discussed, that is principal quantum number, L is the azimuthal quantum number and ML is the magnetic quantum number. The next is spin quantum number. It describes the spin of electron because electrons are in a spin, either is in the clockwise direction or in the anti-clockwise direction. It is represented by ms. So if the electron is in clockwise spin, then the value of ms is +12, and if it is in anti-clockwise anti-clockwise, then it is represented by ms is equal to -12. So thus the spin of an electron can be determined by the quantum number, which is called as spin quantum number, that is +12 for clockwise spin and -12 for anti-clockwise spin. So thus we have discussed about the 4 quantum numbers. These quantum numbers is actually describe each electron in an atom in a different orbitals. So there are 4 set of quantum numbers here, which are principal quantum number, azimuthal quantum number, magnetic quantum number and spin quantum number, from which principal quantum number is represented by small n, azimuthal quantum number represented by L, magnetic quantum number represented by ML and spin quantum number is represented by ms. So in the next video we'll be discussing problems on this. It is a very most important topic in this chapter, so you need to practice problems on this. In the next video we'll be discussing problems related to quantum numbers. So all of you go through this properly and make a proper note for this. Thank you everyone.